Hey guys, in this video, I am going to teach you how to get rid of a radical in the denominator using a method called rationalizing the denominator. So the steps to do this is first to multiply the numerator and the denominator by whatever radical is in the bottom, so in the denominator of the fraction. And then you're going to simplify the radical, okay? Because remember from the last video, I said you're not allowed to have a radical in the bottom of your fraction, so we need to fix that. Sometimes it doesn't just go away like it did when we were doing the division problems earlier, so you have to actually do something different, and that's what we would do in this video. I would still start by looking to see if you have any perfect squares and taking care of those first. So if I'm looking at problem 1, 10 and 3 are not perfect squares, so I'm going to have to rationalize. And when I said multiply the numerator and denominator by the radical, I mean multiply the top by radical 3 and the bottom by radical 3. And the reason you can do this is because radical 3 over radical 3 is just 1. So technically you're still multiplying by 1. Now, both of these are radicals, so I can multiply them together. Square root of 10 times the square root of 3 is square root of 30 over 3 times 3 is 9, so radical 9 on the bottom. So the bottom is now a perfect square. So I can take the square root of that and get 3. So I have radical 30 over 3. Now, are there any perfect squares that go into 30? Let's find out. 30 divided by 25 does not work. 30 divided by 16, nope. 30 divided by 9, nope. 30 divided by 4, nope. All right, so that means there are no more perfect squares that fit, so we are all done. All right, number 2. Same thing, neither one of these are perfect squares, so we're going to multiply the top by radical 6 and the bottom by radical 6. 2 times 6 is 12, so I get radical 12 on top. And I get 6 times 6 is 36, so radical 36 on the bottom. The square root of 36 is 6. And then I know that radical 4 goes into 12, so I'm going to get radical 4 times radical 3. Square root of 4 is 2, so 2 radical 3 over 6. And then lastly, these two whole numbers here, the ones that are not underneath the radical, you want to see if you can simplify them. 2/6 simplifies to 1/3, so you get 1 radical 3 or just radical 3 over 3. All right, number 6. Again, we don't have a perfect square, so we're going to multiply the top and the bottom by radical 6. Now this time, the 4 is not under a radical, so I cannot multiply the 4 and the 6 together, so it just stays 4 radical 6. And then on the bottom, 6 times 6 is 36, so I have radical 36. The square root of that is 6, so 4 radical 6 over 6. And 4 over 6 simplifies to 2/3, so 2 radical 6 over 3. All right, number 4, radical 12 over radical 5. Neither of those are perfect squares, and 12 is not divisible by 5, so I can't simplify there. Multiply the top by radical 5 and the bottom by radical 5. On the top, you're going to get radical 60. On the bottom, you get radical 25. The square root of 25 is 5, and we need to see if there are any perfect squares that go into 60. So 60 divided by 49, then 36. 25 isn't going to work. But 4 does. It's 4 and 15. So radical 4, radical 15. Square root of 4 is 2. So 2 radical 15 over 5. And 2 over 5 does not simplify, so that's it. That's your answer. Okay, number 5. 3 and 8 are not perfect squares, so multiply the top and the bottom by radical 8. 8 times 3 is 24, so we'll have radical 24 on top, and then we're going to have radical 64 on the bottom. I know that 4 goes into 24, so it's going to be radical 4, radical 6 on top, and the square root of 64 is 8. Then we get 2 from square root 4, radical 6 over 8, which simplifies to 1 radical 6, or just radical 6, over 4. Number 6, once again, no perfect squares. Multiply the top by radical 27 and the bottom by radical 27. 27 times 11 is 297. So I get 2 radical 297 over radical 729. Now the square root of 729 is just going to be 27. So on the bottom I get 27. And we need to see if there are any perfect squares that go into 297, which is a pretty big number. So let's see. We're going to start at 289. So 297. Nope, that's not going to work. 256 isn't going to work. 225 won't work. 196 doesn't work. Nine works. So radical 9 times radical 33. Now the square root of 9 is 3. So 3 radical 33 over 27. And 3 over 27 is going to simplify to 1 over 9. So radical 33 over 9 would be our answer. All right, a few more. First we have the square root of 20 over 4 radical 3. 20 and 3 are not perfect squares, and 20 is not divisible by 3. So I'm going to multiply the top and the bottom by radical 3. So in the top, we're going to get radical 60. And the bottom, we get 4 radical 9. The square root of 9 is 3. So now I have 4 times 3 on the bottom. I think we did 60 earlier. It's up here. 4 is the biggest perfect square that goes. So 4 and 15. The square root of 4 is 2. So 2 radical 15. Over 4 times 3 is 12. And then 2 over 12 simplifies to 1 over 6. So you get radical 15 over 6. All right, next one. 32 over 4 does simplify. So I'm going to get 9 on the top and radical 2 on the bottom. 2 is not a perfect square, so we're going to go ahead and multiply by radical 2 on the top and on the bottom. Now remember, the 9 is not in a radical, so you can't actually multiply it with the 2. So we're going to get 9 radical 2 over radical 2 times radical 2 is radical 4. And the square root of 4 is 2. So 9 radical 2 over 2. 9 over 2 does not simplify. And remember, you can't do anything with the radical 2 and the 2 because one is in a radical and one is not. So that's it. That would be your answer for that one. Last one. Radical 27 over radical 3 can actually be divided because they're both in the radical, and 27 divided by 3 is 9. So I have radical 9 on top and 12 on the bottom. The square root of 9 is 3, so I have 3 over 12, which simplifies to 1/4. So that one was probably the easiest one, just because it simplifies first. And that's it. That is how you simplify radicals and denominators using rationalizing the denominator.